Quiz 11. Determine the volume in milliliters occupied by 300 grams of mercury. And we have the density of mercury. So density is equal to mass over volume. We want to determine the volume, so if we cross multiply and divide, we get the formula, the volume is equal to the mass divided by the density. Well, we have 300 grams of mercury, and the density of mercury is 13.6 grams per cubic centimeter. Now, one thing that we should know is this is going to give us something in terms of cubic centimeters. But you should remember that 1 cubic centimeter is equivalent to 1 milliliter, okay? So we're going to take 300 grams and we're going to divide that by 13.6. And we're going to get 22.1 almost. 22.1, and then that would be cubic centimeters, which is equivalent to 22.1 milliliters. So right there. Determine the mass of an aluminum cube with side lengths of 2 centimeters. Okay, so we want to find the mass this time. Well, density is equal to mass divided by volume, and if you want to find the mass, you multiply both sides by the volume. And so the mass is going to be the density times the volume. Well, the density is 2.7 grams for every cubic centimeter. And let's see, we're talking about a cube, so we have to find the volume of a cube. And each length of the cube, it's going to be a length times a length times a length. So that's going to be the length cubed. So we're talking 2 centimeters, and we have to cube that. This is going to give us the mass in grams. Cubic centimeters are going to, they're going to drop out. So we're going to get 2.7, and we have to multiply that by 2 times 2 times 2. And I get 21.6. So 21.6 grams. A student obtains 12 milliliters of water in a 25 milliliter graduated cylinder, and a 4-ounce irregularly shaped object is placed in the cylinder, and the water level goes to 22.8 milliliters. Determine the density of the object and its identity. Well, all right, so we have this graduated cylinder, and I'm going to just put a cylinder here, and we have 12 milliliters of water. And then when we put the cylinder, the irregularly shaped object in the cylinder, then the water level goes to 22.8 milliliters. 22.8 milliliters. So this is, we can get the volume, and this is called by water displacements. We put a odd-shaped object into water, see where the water level rises to, and then we can determine what the volume of that object is. So we know the volume of this object is going to be this 22.8 milliliters minus this 12 milliliters. So you have 22.8 minus 12, so that's going to give you what, 10.8 milliliters? So that's the volume of the object, and we know it was 4 ounces. So we know that it had 4 ounces. And so 4 ounces, that's, let's see, there's 16 ounces in a pound. And there are 2.2 pounds in a kilogram. And then there's, in each kilogram, there are 1,000 grams. So we can find its mass, and we have its volume, and then we want to find out what its density is, right? I mean, that's the goal here. We want to find out what it is. That's a mass divided by a volume. So let's find out what the mass is. So we have our 4 ounces divided by 16 divided by 2.2 and multiplied by 1,000. and we have 113.636 grams. So 4 ounces divided by 4 ounces, yeah, divided by 16 ounces divided by 2.2 pounds multiplied by 1,000, we get that 113.6 grams. And so that's what this is. And we found out its volume is 10.8 milliliters. And so each milliliter is equivalent to a cubic centimeter. So the milliliters drop out. So 113.636, 113.636, right, divided by 10.8. And so that's going to give us 10.5, and that's going to be 10.5, and that's going to be grams per cubic centimeter. So we have some things here, and silver has a density of 10.5 grams per cubic centimeter. Gold is 19.3, and aluminum is 2.7. So we got 10.5. So gold is not going to be the right answer, or aluminum, but silver, Ag. This is 10.5 grams per cubic centimeter. So we know without a doubt that we have a piece of silver. What's interesting is that I'm rattling off these names of these elements, and I called this silver and gold and aluminum. Now again, we're going to be talking about these elements. We're going to be introducing the periodic table this week. So if you don't know the names of these elements, don't worry about it. Just, we'll work on it in a couple days, and you will learn them. So just be patient, and you'll get there. So let's move on. Pumice has a density of 0.951 grams per cubic centimeter. Will pumice float on water? Well, you can float on water if you're less dense than water. If you're more dense than water, then you cannot. So pumice has a density of 0.951. So it's less. The density of water is 1 gram per cubic centimeter. So will it float on water? Yes, it will float on water because it's less dense. Will it float on gasoline? Well, the density of gasoline is 0.670 grams per cubic centimeter. So will it float on gasoline? No, because it's more dense than gasoline. So float on water? Yes. Float on gasoline? No. A cookie recipe requires 1 cup of sugar, which has a mass of 200 grams. Determine the volume of sugar. And so the density of sugar is this. So we have density is equal to mass divided by volume. And we want to find the volume. So that's going to be the mass divided by the density when we cross multiply and divide. So the mass then is 200. 1 cup is 200 grams, and the density is 1.59 grams per cubic centimeter. So we take 200 and divide it by 1.59, and we're going to get 125.8 roughly, 125.8, and that would be cubic centimeters. So we look over here, 125, that's pretty close to 126. In units of liters, determine the volume of 10 pounds of air. And we have the density of air. Well, okay, we want to find the volume again. Well, volume then is mass divided by the density. And we have 10 pounds of air, 10 pounds. Well, that's not a mass, that's a weight. And so there are 2.2 pounds in a kilogram. And we have to convert from kilograms into grams. Now I know I had to convert to grams because my density has units of grams per cubic centimeter. So that's why I did that. Get rid of the pounds, get rid of the kilograms. I'm left with grams in the numerator for mass. Had to be in grams because the units have to cancel out. So the density of air is 0.00129 grams per cubic centimeter. So the grams in the numerator and the denominator will drop out. The denominator of the denominator, which is the cubic centimeters, that will move to the numerator. And so let's do our math. We have 10 divided by 2.2 multiplied by 1,000 and divide by 0.00129. And we're going to, we get a huge number. We have 3.5236, put some digits on there, times 10 to the 1, 2, 3, 4, 5, 6, times 10 to the 6 cubic centimeters. Okay, now we want the answer in terms of liters. So we have 3.5236 times 10 to the 6 cubic centimeters. And every cubic centimeter is 1 milliliter. And then there are 1,000 milliliters in a liter. So I have to divide this by 1,000 now. And that's going to give me 3,524 roughly. 3,524 liters. So 3520, that looks the closest. 3520 liters. A spherical container can hold a maximum amount of 500 grams of honey. Determine the radius of the container. Well, the honey is let's see, the density of honey is 1.42 grams per cubic centimeter, and it's a spherical container, so we have to have the volume of a sphere. And so density is equal to mass divided by volume. So let's get the volume first. Density is mass over the volume. So the volume then is the mass divided by the density. And we have 500 grams of honey divided by 1.42 grams per cubic centimeter. So 500 divided by 1.42 grams per cubic centimeter, and we get 352 roughly cubic centimeters. So that's the volume. Now the volume is going to be of a sphere because it's a spherically shaped container, and the volume of a sphere is 4/3 pi r cubed. So we know the volume is 352 cubic centimeters. That's equal to 4/3 pi r cubed. So we just have to solve for r. So we have 352 cubic centimeters. We multiply by 3, divide through by 4, and divide through by pi. And so now we have to take the cube root of this, and we get 4.38. We get a radius of 4.38 cubic not cubic centimeters, you're just centimeters, because when you take the cube root, it'd be just centimeters. So yeah, the radius is 4.38 centimeters. Right there. Determine the density of water in units of kilograms per cubic meter. So water is 1 gram per cubic centimeter. And we want to go to kilograms per cubic meter. Well, the kilograms part is easy. We have 1,000 grams is a kilogram, so we already have the numerator. And we want to go per cubic meter. Well, there's 100 centimeters in a meter, and this has to be cubed. So we're done. So we have 1 divided by 1,000, and then multiply by 100, multiply by 100, and multiply by 100, and we're going to get 1,000. So we get 1,000 kilograms per cubic meter. Which has a greater mass, 100 cubic centimeters of copper or 100 cubic centimeters of lead? So you want to find out which one has the largest mass. Well, we have a formula that says density is equal to mass divided by volume. So let's try to figure this out without doing any math. Let's just say, okay, the volume is the same for both. So let's solve for the volume, which again is the mass over the density. Boy, we just can't get away from this. Take the mass divided by the density. So we want to find out which one's going to have the greatest mass. Well, this is a direct proportion. The direct proportion says the one with the largest mass must have the largest density because this is a direct proportion. So the one with the largest density is lead. So it should be, your answer should be lead. And we didn't have to do any math. So what we do is, let's just do the math. Density then is equal to mass over volume, and we want to find the one with the largest mass. So now we solve for the mass, which is density times the volume. So let's solve first for the copper. And the density of copper is 8.89 grams per cubic centimeter, and the volume of the copper is 100 cubic centimeters. 100 cubic centimeters. So the centimeters drop out, and we're going to get 889 grams is the mass. So let's do it again for the lead. The mass of the lead is equal to the density of the lead times the volume of the lead. And the density of the lead is 11.3, and that's going to be grams per cubic centimeter, multiplied by the volume of 100 cubic centimeters. And so we're going to get 1,130 grams. So definitely the lead, this is the mass of the lead, this was the mass of the copper. Definitely the lead is the answer. A 14 gauge copper wire has a diameter of 0.06410 centimeters and a mass of 27.4 grams. Determine the length of the wire in units of meters. Okay, well, density is equal to mass divided by volume. All right, so we have the mass of the wire, and we have the density of the wire. So let's solve for the volume. The volume is going to be the mass divided by the density, and the mass is 27.4 grams, and we have to divide that by 8.89 grams per cubic centimeter. And so 27.4 and divide that by 8.89, and we're going to get 3.08 cubic centimeters. Remember, the grams drop out and the cubic centimeters are moved to the numerator. Well, we have this wire, and this wire is drawn out, and we know what its volume is. A wire is like a cylinder, and so the volume of a cylinder is what we need. The volume of a cylinder, if you remember, is pi r squared h. And h then would be the length of the cylinder, or the height of the cylinder. So we have 3.08 cubic centimeters is equal to pi times the radius, and we don't have the radius, we have the diameter. So the radius is the diameter over 2. So we're going to have I'll put 0.0641, and that was centimeters all over 2. It's a little hard to read through there. I apologize for that. So we have the pi times the radius, and we have to square that, times it by the height, or the length of the wire. So let's solve for h, and we're going to have 3.08 cubic centimeters, and we're going to have to divide that by pi. We're solving for h now, so we have to divide by pi, and then we're going to have a 2 divided by 0.0641 in centimeters, and then we have to square that. So all I did was just invert this ratio. So we're going to have 3.08, and we're going to multiply it by 2 And then that 2 is squared, so we have to multiply it by 2 again, and divide through by pi, and divided by 0.0641, and divide that by 0.0641 again, because it's squared. And we're going to get 954, and that's going to be in centimeters. That's going to be centimeters, because notice the centimeters squared is going to cancel out the centimeters cubed, but there will be one more unit of centimeters up here. So 954 centimeters. And now we go back to the question. Determine the length of the wire with units of meters. Well, 954 centimeters, there are 100 centimeters in a meter. So we just divide by 100, and we'll get 9.54 meters. Looks like right there, 9.55 meters. There was a lot of calculations, a lot of math, but follow the steps. They're easy to do. So once again, have a great day. Enjoy it.